Hello and welcome to the crash course of derivatives part 2. So here we're going to be looking at a little bit more complicated examples of derivatives. Now please note this will make very little sense if you don't know what a function is. I have a video on functions. I don't want to not use functions because it will be just difficult to use examples over and over and over again. So now let's get started. So first, a bit of notation. If I have a function f of x and I want to take the derivative with respect to x of this function, it is just denoted as f prime of x, and we have this little dash here. So now that we have that out of the way, let's actually get started into the content. So I want to take the derivative with respect to x of f of x times g of x. How am I going to do this? Well, this is known as the product rule. So this equals, and just bear with me because there's going to be a lot of accept and move on. So the original function times the derivative of the second function plus the derivative of the first function times the second function. And that's that. So if we want to do an example, I have x and I want to times it by x plus 1 squared. I want to first look at the first function, times it by the derivative of the second function. So we can actually label these. Our f of x equals just x, and our g of x equals x plus 1 squared. When we take the derivative, it will be the first function, f times the derivative of the second function, plus the derivative of the first function, which is just 1, times the original function, so we get x squared. Let's moving on to the quotient rule. So here we have two functions being divided by each other. And I want to take the derivative of this. Now this becomes really painful as well. This is the derivative of the first function times the second function minus the first function times the derivative of the second function over the second function squared. You can see where this can become really complicated as you get to harder and harder examples. So the last rule that I want to show you is known as the chain rule, and that's when you have derivative to respect of x that looks something like this. We have a function, and inside that function we have a function, and something like that, something like this would look like root x squared plus x over 2. So we have a function f, which is just square root, and inside that square root we have another function, which is x squared plus x over 2. So what is that going to turn into? It's going to turn into this. It's going to become the derivative of the first function with the second function untouched, and then we're going to times it by the derivative of the second function. Now that we know how to take derivatives, what is the point? Why would we need this? What is some applications? So, if I want to maximize or minimize something for some curve, there's the maximum there. I can set the tangent line, the gradient of the tangent line, to equal 0, and then we can solve for x or y or r or whatever it is. And then you can find the maximum or minimum because they're both going to have this derivative of 0. Now what you find depends on your function. So if we have a function like this, we're going to find a minimum. But if we have a function like this, we're going to find a maximum. those critical points that you need to realize which one am I actually looking for and how do I make sure I'm getting the right one. There is another thing that you can do, and that is take the derivative of the derivative. So if I have dy over dx, and then I want to take the derivative of this d over dx, we have a special notation. We get the d's up the top squared, take y, and then the x's squared. And that's just a fancy way of writing what this is up here. These two expressions are equivalent. So what we're essentially doing is we're getting the derivative f of x, and then I'm going to take the derivative of that, and we can put a line up here to show the derivative. So this is known as the second order derivative, and we can expand this more, and we can change the notation so we have 2 dashes instead of 1 up here. That just shows the second derivative. You can also expand this more generally. If I want the n order derivative with respect to x, we can show that I'm taking the derivative n many times of any given function. So that's all I have time for today for this crash course on derivatives. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.